In this video, we're going to discuss the hypothesis test for goodness of fit using unequal frequencies. We'll start by looking at the requirements for this test. In the goodness of fit unequal frequencies, we are testing whether an observed frequency is equal to some claimed frequency. Now, the observed frequency is gathered experimentally, meaning that we've done an experiment and gathered this data, and usually that's in the form of a random sample. The expected frequency is gathered theoretically, meaning that at some point in time a researcher has looked at the data from a company and has decided on some values. In every case for this particular hypothesis test, all of our variables are qualitative. Remember, that means that the variables are a category and are not numerical values. The data is from a single random sample, and the expected frequency for each category has to be greater than or equal to 5. Let's look at the null and alternative hypothesis for this. The null hypothesis will say that the frequency counts agree with the claimed observation. So basically we are saying that what we observed as the result of our sampling technique is equal to what the company is expecting the frequency to be. The alternative hypothesis is that the frequency counts don't agree with the claimed distribution. We're going to look at this example and use it to run through StatDisk. So Baseball Cards USA prints baseball cards. The company claims that 40% of the cards are rookies, 50% are veterans, and 10% are all-stars. However, you don't believe that this is the case. So what you want to do is you collect a random sample of 200 cards. And you find that there are 95 rookies, 65 veterans, and 40 all-stars in this collection of cards. What you want to know is whether the sample that you have collected is consistent with what Baseball USA claims. And you're going to use a 0.05 level of significance to do this. Our next step is to test out whether this scenario meets the requirements for the test we're trying to perform. We are testing if the frequency distribution from our random sample, that's the experimental, is equal to the company's claimed distribution, that's the theoretical. So we are testing whether the experimental and the theoretical are the same. Our variables are rookies, veterans, and all-stars, and all three of those are qualitative variables. We gathered a single random sample of 200 baseball cards, and the expected frequency for each of our categories is equal to 5 or greater than 5. So this meets all of the requirements for the goodness of fit unequal frequencies hypothesis test. Next, we're going to state our hypotheses based on this scenario. So the null hypothesis is the distribution of baseball cards is 40% are rookies, 50% are veterans, and 10% are all-stars. The alternative hypothesis is the distribution is not 40% are rookies, 50% are veterans, and 10% are all-stars. Before we go into StatDisk with this problem, you will need to notice that we're given the information in two different formats. The company gave the distribution of the baseball cards in percentages. However, when the sample was conducted, the results were given in counts. And when we go into StatDisk, we need to have one or the other of these. So I'm going to use counts. And what we need to do then is to take the percentages that the company reported and the sample of 200 cards that the experiment used, and determine how many cards would fall into each of these categories. So we would do 40% of 200, which is 0.40 times 200, so we would get 80 cards. 50% would be 100 cards, and 10% would be 20 cards. And so what I've done is I have summarized the expected, which is the company distribution, and the observed, which is the sample, in the table to the right, and they are all done in counts. We're counting cards. We're now ready to go into StatDisk and perform our calculations. So remember that the first thing that you will see in StatDisk is the sample editor. And we're going to enter our data. I entered the company data or distribution, which is the expected, in column 1. And remember that was 80, 100, and 20. I entered the sample data or the observed in column 2. And that, remember, was given to us as 95, 65, and 40. Once we have that data entered, we're going to go to Analysis at the very top of the StatDisk screen. We're going to choose Goodness of Fit from the pull-down menu and Unequal Frequencies. Once you do that, the left-hand side of this screen will appear. The menu will come up with a default significance level of 0.05. So you have to be careful if you have a different significance. Now we don't, so we can leave it as 0.05. Then the default for the expected frequencies is as proportions. However, we did ours as counts, so we're going to need to change that button to as counts. The next thing that we need to do is to tell StatDisk which column contains the observed and the expected frequency. So remember, I put my observed sample data in column 2 and my company expected values in column 1. So I set that up accordingly. Once we have all of that set, you're going to click Evaluate. When you click Evaluate, the right-hand side of this screen is populated with the results. And note that the p-value is 0. We are now ready to talk about the conclusion statement. Remember that the conclusion statement has a prescribed format. First, you do a comparison of the p-value and the level of significance. Second, you tell whether the null hypothesis is rejected or not. And last, you give a synopsis of the hypothesis that is supported by the data. So our conclusion statement is, since the p-value of 0 is less than the level of significance of 0.05, the null hypothesis is rejected. Therefore, the data supports that the distribution of baseball cards is not 40% rookies, 50% veterans, and 10% all-stars.